podcast. Today I have Ryan Elliott with me. He is a co-founder and CEO of In Orbit Aerospace, a company that specializes in setting up infrastructure in space to manufacture different products in various industries. So welcome. Hi, Ryan. Introduce yourself. Tell us a little bit about yourself and your company.
Awesome. Yeah, thank you. It's good to be here. So I'm Ryan. I'm one of the co-founders and the CEO of In Orbit Aerospace. As you mentioned, we're providing end-to-end services for in-space manufacturers and researchers. So I've got an engineering background and have been formally working at this company for about 2 years now.
Awesome. Thank you so much for joining. So the first thing I want to get into is just the origin of your company. So take me back to the time in your life before you started In Orbit. Where was the inception of the idea? Where did it come from?
Yeah, this actually goes back about 10 years from
Mm-hmm.
where the first seed was planted. I did my undergrad in physics.
Mm-hmm.
I didn't know what I wanted to do before that. So I figured let's start at the fundamental basics, learn a lot of great stuff. It'll be a good foundation.
Mm-hmm.
And I expected to go in learning all of these awesome concepts about like black holes, quantum physics, and a lot of concepts that were on a TV show called The Universe. If you
Mm-hmm.
remember, it was probably one of the last good
Not at
TV
all.
shows on the History Channel, right? But it had Neil deGrasse Tyson on it, and I think Michio Kaku
Mm-hmm.
was his name, and really, really great visuals. But when I got to
Mm-hmm.
undergrad and I did physics, it was just math. It was just someone like writing on the board and being like, "Do you understand?" And it's like, "Yeah, but this is not exactly what I was hoping to do when I got here."
Yeah.
But I got a lucky job just because I was one of the few people that talked a lot in the undergrad room. I guess they
Mm-hmm.
said I thought I was a good speaker, and that turned out to be teaching space camp at Kennedy Space Center. And
Oh, that's
this was
cool.
a startup. Yeah, it was a startup. I showed up, worked as an intern. I was there for the very first class they had. I stayed on after, and kind of ended up running the day-to-day operations with the person who helped me get the job. And we did
Mm-hmm.
thousands of students every year teaching rockets, robotics, high altitude science with the weather balloons. We launched those.
Mm-hmm.
And we also, of course, talked a lot about what NASA did, the space shuttle and the International Space Station. Um, so learned a lot about what microgravity research and science goes on in space,
Mm-hmm.
and was really interested in that. We had this NASA engineer on site to help us with a competition we were helping run one, and we went out to dinner, and just
Mm-hmm.
kind of out of curiosity, I asked like, how small could the space shuttle be? Well, the real one is very large, and I was kind of expecting him to say like 20 or 30 feet long. Was we looked into this, but no, this guy pops his hands out. It's like the size of a loaf
Mm-hmm.
of bread,
Yeah.
and I was just like blown away. I was like, that's awesome. Somebody needs to go
Yeah.
build that, and
Mm-hmm.
it's going to be me. So I started kind of like plotting how I was going to get out of
Mm-hmm.
education and into the industry.
Yeah.
Um, I went to grad school. Went to University of Leicester in the UK.
Mm-hmm.
They had a great program that worked on lunar and Martian exploration, and we did our master's thesis on an architecture for that involved
Mm-hmm.
launching many things over a period of 20 years and eventually building space stations and going to Mars, which was a great project. Learned a lot about just a all general foundation of space systems.
Mm-hmm.
Um, but the other half of our cohort was working on a project that was sponsored by the ESA, and this was a successor to the ISS, or alternative platforms to get to space and back for microgravity research. And
Mm-hmm.
I really, really took an interest in that, at least from looking and paying attention to that project while we were doing ours, because it was very much similar to that little space shuttle,
Mm-hmm.
and and it was because it was sponsored by the European Space Agency. That meant that there is a government space agency interested in furthering research and manufacturing in space. There's also, it's technically possible to make a smaller reentry vehicle. So I was like, well, there could be a business idea here. Um,
Mm-hmm.
I graduated and I got a first job in Los Angeles. I was working for a company called SAIC.
Mm-hmm.
Uh, And I moved about 5 blocks down the road with a colleague from grad school. And we met up for coffee one day and talked about that idea. And we were like, well, the only missing piece here is like, could this
Mm-hmm.
be a commercial business?
Right.
And started looking up like what kinds of things do people want to make in space and bring back to the ground. Could they be profitable? And the other side of that is, could we make something? Is it actually technically feasible? And
Mm-hmm.
could we do it cheap enough such that there could be profitable businesses made off of the materials we ship to and back? The answer was kind of overwhelmingly yes. So
Yeah.
after doing a little bit more work and making our initial pitch, we um, got enough friends and family money to jump off full
Mm-hmm.
time, and that was about just about 2 years now.
Mm-hmm. No, that's amazing. I think you've kind of had that slow progression of like jumping into the idea. And I think it sounds like you had a lot of different things like throughout your years of like education and like your early career that kind of like pinpointed you towards the direction of launching this company. Even the fact that you were when you were an undergrad that you're a good speaker, and even the information that you found out about um, something that you launch into space can be much smaller. Like maybe that's something that a lot of people might not have like thought to ask that, and it sounds like you asked the right person, and that idea kind of was originally like incepted, and you shared it with the right people, and you had the right co-founders to leverage that idea and like help you fill in the pieces that maybe that you had not thought of yourself. So that take me back to 2 years ago when you did decide to launch the company. Was that an easy decision for you? What was your thought process back then?
I think, we probably could have launched it earlier. I think a lot of what held us back was we were engineers. We didn't know how to start a
Hmm.
business in the first place. And that was the hardest part to learn. And
Hmm.
I think, but I think it was still a good time. I think it was good that we waited.
Hmm.
We got to a point where it was like, we got to do something about this, or 10 years from now, we're going to think that we just waited around and didn't do anything. And we would definitely regret that.
Yeah.
Um, and we were, you can only do so much after work if you have a 40-hour, 50-hour a week job.
Hmm.
And if you're spending all that time and then you're spending all your weekends, like it's not exactly great for mental health either. So
Yeah.
at some point we were like, this is gonna, we're extremely confident in this, and we believe not just in
Hmm.
like the technology, we believe in this like business, and we think like the time is right in the space industry now.
Hmm.
Let's go talk to our friends, close friends and family, and see if they would buy
Hmm.
on. And and it was like, yeah, sure. They managed to at least give us enough that we were confident to spend a few months or six
Hmm.
months trying to build the business and raise more from more institutional investors. That it seemed worth the risk.
No, that definitely makes sense. Sometimes getting from that like 0 to zero point 0.5 can be harder than getting from zero point 0.5 to 1%, and I think that's probably maybe the reasoning behind why it was a slow start. But once you got into it, I'm sure the work that you put in the previous years about thinking about the idea or conceptualizing, and then once you kind of figure out the details of how to launch the business and how to set up the business and get more funding and get like outside investors, I'm sure that kind of helped you go to the next step a little bit faster over the years. So it definitely makes sense. And I think a lot of founders definitely have that dilemma of should I do it? Should I not do it? I want to get a little bit into your relationship with your co-founders. Tell me about how you know them. How did you guys come together? How did you know that was the right team?
Yeah. So there's two of us. There's myself, and then there's
Mm-hmm.
Antonio, who's the COO. I met him first, and he brought in the third, Ishan Patel.
Mm-hmm.
He had worked on like a specifically docking spacecraft in flight, uh,
Mm-hmm.
which is like a very particular niche area and something that
Yeah.
is a big focus of our business. So it made sense to bring him on as CTO. He is probably the most risk averse of us. I'm
Mm-hmm.
probably the riskiest, so it's a good
Yeah.
balance.
Yeah.
Antonio is kind of right there in the middle, and he will
Mm-hmm.
often kind of be that devil's advocate for
Tiebreaker.
whatever side.
Yeah.
Yeah, that as well. And he makes a good COO because he's just like really on the ball about kind of everything. Like if something needs to get done, like he can get it done. He can manage a lot of different things at once. And whether it's doing like professional engineering design or just general documentation, or he's actually a pretty good designer. Kind of everything that he outputs is professional
Mm-hmm.
looking. So it's really interesting what you said about like going from
Mm-hmm.
0 to 0.5 is and
Mm-hmm.
compared to going from point 0.5 to point 0.1 or 1. I always think that I'm good at taking things from 0 to point 0.5 and then like passing it off
Mm-hmm.
and going from half to 1. It's always easier to improve on something than it is to
Yeah.
create something from scratch. So just
Mm-hmm.
like I'm just a fan of like diving in and let's get something started, and then other people can
Yeah.
scrutinize it. They'll probably tell me that I'm
Mm-hmm.
wrong, and that's okay. Sometimes that's part of the job.
I think that's a
Yeah.
great mindset to have. Those 1% improvements is how you're going to get to the next level. Even with this
Mm.
podcast, I just had to jump in and start doing it. Like the first episode didn't even have video. Like you see the second episode, it's not even like framed correctly. Like there's so many things like I learn even within each time I'm like recording or each time I, ask someone for feedback. There's different things that I wouldn't have thought about to improve upon, but you kind of have like you have to push yourself to get from that 0 to zero point 0.5, and then you can figure out who to bring in, who's going to add value to your team. So it definitely sounds like you have a really balanced team and you guys have a good working relationship and you are bringing different skill sets. And I'm sure that empowered your work environment. Tell me about a situation if, what about things that you guys don't agree on, or what are some things that you've struggled with, and how have you dealt with keeping the team effective and like communicate those obstacles as you're building your company?
I can. That's a great question. I'm not going to lie, we disagree on a lot.
Uh-huh.
Um, there's
Yeah.
just so many things that come up
Mm-hmm.
in the midst of trying to build, not just like build a space company, but we're also trying to like expand this very niche and particular industry.
Mm-hmm.
But we always end up coming out of it like, okay, we've never had like massive fights or anything.
Yeah.
Um, I think if there's one thing that's sometimes it could be like who do we need to hire next, or what should our hiring plan need?
Mm-hmm.
What should it be? Depending on like if you ask somebody who's more mechanically inclined, they're going to tell you that they need like 3 structural engineers and 2 mechanical
Mm-hmm.
engineers, and the same with someone who does like software is probably going to say like they need 5 software, and if like me
Mm-hmm.
on the business and sales side would like it would be great if I just had a suite of salespeople. You wouldn't need any
Mm-hmm.
engineers. I could just sell all day.
Yeah.
So that's something we go back and forwards on. We have it pretty well nailed down now after going through this for quite a while.
Mm-hmm.
Um, Other than that, it's probably always just has to do with like very particular things around
Mm-hmm.
funding and the use of like funds, especially in the beginning when it's that there's this like problem of like how do you
Mm-hmm.
adequately cost what a spacecraft is, how much is it going to cost to build the spacecraft? How do you account for all of that?
Yeah.
Um, and big companies are really good at it because they have loads of heritage, they have loads of metrics.
Mm-hmm.
But as a new company, you don't have access to all of that kinds of information as well.
Oh, that,
So
that makes
we're doing
sense.
a lot of detail on that. Yeah. And kind of our costing model and our spreadsheets now are like so modular and so
Mm-hmm.
kind of like detailed and precise that we eventually converge to this is how we're going to do it. This is what the source of
Mm-hmm.
truth is going to be. Uh,
Yeah.
but a
No,
lot of
that makes sense.
compromises. I can say that.
Mm-hmm.
Yeah.
Especially with an emerging technology, you don't really have much precedence to rely on, and you don't have the resources of a big corporation either. So definitely makes sense that you had to have those disagreements to figure out what the right path was. So that's great. Like I think that's really insightful to know how you guys are resolving your conflict, and so that kind of takes me into wanting to ask you about different skill sets that you were leveraging. And I know that you mentioned that your founding team, you guys were all engineers or had an engineering background. Do you think that like now, as you've taken on the role as like CEO or like CTO or CEO, like do you think that you're still leveraging your skills as an engineer, or do you think you've built a whole other new skill set? I'm kind of curious to know about how you leverage your like prior experience before you started the company.
Yeah, I mean, I'm really leveraging completely new skill sets.
Mm-hmm.
My past, I guess, when I was working at the space camp, there was a lot of talking there. There's a lot of giving
Mm-hmm.
presentations. So that has stayed the same. But I really haven't done that in any sort of work environment since then.
Mm-hmm.
I did a lot of
Yeah.
presentations in grad school, but after that, 3 years that I was working in the industry, it was
Mm-hmm.
mostly as like a systems engineer, and you probably know what a lot of that is like. You might be in
Mm-hmm.
meetings, you might be giving reports in
Yeah.
meetings, but sometimes you're just behind a computer working on a document or a spreadsheet. And so a lot of these have been really new. A lot of networking, a lot of going out to events, a lot of just
Mm-hmm.
reaching out and trying to get on phone calls with people whom you've never met before, and you need to
Yeah.
before the phone call be like, these are my goals for this, and I need to achieve those in 30
Mm-hmm.
minutes, and this is how I'm going to do it. Um, but understanding that it can go anyway, and
Mm-hmm.
halfway through you might think that, you know what, that's not going to happen, here's new goals, I have to transition, doing that on the fly. I've always been somewhat comfortable public speaking. There's always improvements to be made on how to talk about really technical things, or even maybe really new things, such
Mm-hmm.
as manufacturing in space, that the
Mm-hmm.
general public doesn't know about. And
Yeah.
not just talking about that, but of course framing it into a story. That's a
Mm-hmm.
massive part about being a founder, trying to sell not only to customers, but also any other type of stakeholder, whether it be like an investor or maybe someone you want to get an interview from, or
Mm-hmm.
any sort of thing. So that's been a big skill I've had to develop. When it comes to specific engineering type
Mm-hmm.
activities, at the very beginning, probably like the first year, I did a lot more in that area.
Mm-hmm.
Now that our team has grown, we're 8 full timers. We have 3 interns in right now. I'm
Mm-hmm.
able to leverage that off and focus more, but can at
Mm-hmm.
least give a high level perspective of like what needs to be done in order to achieve the goals and the vision that we
Mm-hmm.
set out to do as a company. Um, so, which obviously I miss a lot, but and
Mm-hmm.
um, I'm sure at some point in time, like I'll be able to get back into that. But for now, this is what I got to do.
That makes sense. You have to put on the hats that are most necessary to keep progressing the company. And it sounds like your team has grown quite a bit over the years. That makes me want to ask you this question. If you had always envisioned being an entrepreneur and a founder, or is that something that came about because you had the idea for this company?
I think there was always something, some sort of
Mm-hmm.
spark that wanted to create inside.
Yeah.
Because I didn't know that I was even passionate about the space industry until I got this job working at a space camp. I was doing
Mm-hmm.
physics, I obviously like
Yeah.
science and math, but I didn't even find out I was good at math until 10th grade,
Mm-hmm.
until I started caring, honestly.
Yeah.
Um, I was never like fantastic at it in grade school.
Mm-hmm.
And sometimes I was just never even the kid to do his homework.
Yeah.
That, that actually continued in college. I ended up getting
Mm-hmm.
kicked out of undergrad
Mm-hmm.
at some point, and I had to,
Mm-hmm.
basically get in community college, work hard,
Mm-hmm.
get my grades back up to get back in.
Yeah.
And but I was stubborn enough to want to continue.
Mm-hmm.
Um, but I always wanted to do something different.
Mm-hmm.
I think
Right.
America, in a lot of parts of America, and I don't even mean that necessarily geographically, but maybe
Mm-hmm.
just like it seems as if it's like a traditional path to go to
Mm-hmm.
school, and you get a degree and you go to
Yeah.
work for a company and you work real hard up that ladder,
Mm-hmm.
and then maybe you retire, if you're
Yeah.
lucky,
Mm-hmm.
and that really like bothered me. I think while I was like even applying for schools and while I was in them, I just didn't like the way
Mm-hmm.
that was kind of the only way it was going to be. So it it was a little bit of that, and then it was also getting out of college. Like I
Mm-hmm.
struggled to get a job after getting my grad degree, and for whatever
Mm-hmm.
reason it might be, maybe I didn't leverage a network well enough. Maybe my resume looked bad. Um,
Mm-hmm.
but the same resumes like helps me get multiple jobs after. Sometimes it's just
Yeah.
getting that first one is difficult, but like
Hmm.
it was always like, like, there's so many jobs I applied to. I didn't get that awesome job. I didn't get that awesome job. And eventually it was kind of like, maybe I'll just create an awesome job. And
Yeah.
that was sometimes part of the reasoning as well.
No, that's really refreshing to hear, and I think a lot of people will love hearing that answer. Because I think oftentimes, like you mentioned, there's this kind of preset mold of, who you should be in society. You go to high school, you go to college, you get a job, you work until you retire. I think that framework is definitely antiquated for our
Mm.
generation at the least. And it's not something that at least I find very sustainable. So I think it's great that you kind of had that ideology or like realization earlier on in life, and helped you kind of go in the direction of like, okay, I don't like the jobs that I'm looking at. Maybe I'm going to just create my own. And I also love that, you weren't always necessarily a science nerd. And I think that a lot of people will resonate with that because it can be kind of intimidating to be in STEM. And not everyone is going to be super inclined with being good at math or physics from a really early age. So I think it's great that maybe that came on like a little bit later in life and you had to maybe fail a little bit, and then kind of pick yourself back up. So I think that's great. I think that's definitely different from most people, just like how your company is different than most companies. So I want to get into the technology itself. Could you explain a little bit more about what exactly is manufacturing in space? How does that work?
Yeah, yeah. So, when we talk about manufacturing in space, it's not
Hmm.
building spacecraft or space structures or space stations, whatever it may be, and
Hmm.
leaving them in space. It's making materials from their from their raw materials, from their base products, and then bringing them
Hmm.
back down to Earth.
Yeah.
And the reason we do that is because when you take gravity away, it completely changes the game for how you make materials. On
Hmm.
Earth, gravity it creates a lot of different physical phenomena that don't happen in space. So one example that might be easiest to visualize is
Hmm.
heat, and heat on Earth rises.
Hmm.
And you could think of like a lava lamp. Might be a good one. And
Yeah.
when heat rises, you get a lot of convection, or there's convection, and that creates turbulence. And even in like fluids that are solidifying, like glasses or semiconductors,
Hmm.
this turbulence and these kind of this noise nearly can create defects as a material solidifies, and that affects its performance
Hmm.
significantly, especially these days when we're so advanced that getting that extra
Hmm.
1% or like 5% increase in
Hmm.
performance like can make or break a company. And so when you go to space, you don't have
Hmm.
that. Hotter fluids don't rise, denser ones don't sink because there is no
Hmm.
rise and sink because there's no
Yeah.
up or down where we're in a free fall environment.
Hmm.
So there's just dozens, hundreds of different types of materials that we can create better. We can create
Hmm.
newer ones. We can
Yeah.
improve the process, and we can discover more not only about materials, but we can also discover a lot more about ourselves because
Hmm.
biology and pharmaceuticals are a big factor up there as well.
Yeah, no, I love that example, and I'm glad that you broke it down in a way that most people can understand. So that was really great. So I think I want to get a little bit more into, if you could explain. I know you kind of hit on it a little bit already, but elaborate more on what are some unique advantages, as well as like future opportunities for manufacturing in microgravity. Can you maybe give like another example?
Yeah, yeah. So probably the three big areas would be like fiber optics,
Hmm.
semiconductors, and then medicine, biology, and pharmaceuticals. And that one is like just a whole
Hmm.
big beast by itself. So
Yeah, yeah.
on Earth, like the vast majority, 99, 0.99% of optical fibers are silica based, kind of a
Hmm.
refined version of sand. And that's not the only type of material that can make an optical fiber. They're
Hmm.
making them on the ISS now out of a type of glass called Z-bland. That's just an
Hmm.
acronym of the elements. They're like fluoride type
Hmm.
glasses. This one has it's a lower melting temperature than silica. And we can make it on the ground, but because of the disturbances and the heavy elements sinking and hotter
Mhm.
fluids rising and convection and turbulence, you get crystals in the glass. Usually,
Mhm.
glass is amorphous. It's not. It's a kind of the complete opposite of what a ordered crystal is. But when you get a
Mhm.
crystal inside your optical fiber, now you have this. Um, kind of change, and it causes scattering as the light goes through it, and you get a weaker signal coming out of the end. Um, but if we make them in space, those crystals don't happen, and we get a much
Mhm.
more pure signal that doesn't lose energy as it traverses along the length of a fiber. So
Mhm.
the benefit for that is we can replace the cables that connect us and Europe or Asia by
Mhm.
these ones made in space, and we can communicate better. We can reduce the amount of amplifiers we need. It makes the cables cheaper. They also have a wider band gap. We can put more
Mhm.
data down them as well, which in an age where data is ever increasing, then that's
Yeah.
an extremely beneficial use case.
Mhm.
Very similar one for semiconductors. They're a crystal at the end of the day. They have a crystal structure. And
Mhm.
there are defects that are caused when we create them, when they solidify. And
Mhm.
they call them, they have a term in the semiconductor industry, they're called killer defects.
Mhm.
And not not only are we trying to just make them from scratch in space, make the individual crystals themselves, but it's also been shown that you can just take a low grade semiconductor wafer and anneal
Mhm.
it and cycle the temperature and pressure in a
Mhm.
microgravity environment, and it will fix some of these defects.
Mhm.
When it comes to medicines, like a few specific examples is there's a
Mhm.
company called Space Tango that is
Mhm.
trying to they're working with a company called Lambda Vision actually.
Mhm.
They're trying to 3D print retinas in space, and they've had a
Wow.
lot of success. Yeah, and
Mhm.
these are like many different types of layers. And
Mhm.
they weren't getting the results that they needed on Earth.
Right.
And so this can help cure people who are blind for very
Yeah.
specific reasons. But there's still a lot of people that
Mhm.
suffer from the macular degeneration and the other diseases that they're trying to
Mhm.
replace retinas for. Um, Merck has also done experiments
Mhm.
on a cancer drug called Keytruda,
Mhm.
and they've taken the active ingredient, I believe it's pembrolizumab,
Mhm.
up to space in a solution and crystallized the proteins that
Mhm.
make up this pembrolizumab, and they found that they make bigger, or they found that they make not bigger, more uniform sizes of crystals. And the
Mhm.
purpose of this would be to give it as an injection. So
Yeah.
this can, instead of having to get an IV and go to a special hospital that has to keep these IV fluids at a very specific temperature, you can go to your local doctor and you can get a shot. So not only does it
Mhm.
reduce the kind of operational costs for a pharmaceutical company, but it can actually make a patient's experience better for when they have to get treatment. So,
That's amazing.
yeah.
I think all those examples are super insightful and is really like informative to know that there are these almost endless possibilities of what we see now as something that we can apply this technology to. But I'm sure in the future there will be other applications as well. So there's a lot of potential for growth and potential to like increase that value pie as you're going on this journey. And, in the next decades as we're exploring this technology and as it grows, there's going to be so many challenges. What do you think are going to be some key challenges that you're anticipating?
Yeah, there's a lot of technical challenges
Mm-hmm.
to be had, especially when we're not just sending something to space. We're trying to bring something back, which is
Mm-hmm.
a completely different problem.
Mm-hmm.
We also have to, from a business standpoint, we have to make this such that our customers can afford this type of service
Right.
and they can generate enough revenue, they can create
Mm-hmm.
enough materials to actually make a self-standing business
Mm-hmm.
themselves. So we have to find a way to make our spacecraft low cost. They also
Right.
need to be reliable. going up
Mhm.
and coming back down from space. Because I mean,
Mhm.
imagine if you do all this work and you're getting this data and you're like, oh, our materials they're created,
Yeah.
they're done, the manufacturing process is finished, and then you go to bring them
Mhm.
back and something bad happens. That would be
Right.
you might be able to say that would nearly be worse than it not working right when
Mhm.
it got up there. Like we had all this
Mhm.
kind of anticipation and excitement.
Yeah.
Um, and then supply chain is a
Mhm.
really big issue because we don't only depend on a supply chain, but we are a
Mhm.
supply chain.
Yeah.
So we have to have a robust system there. We have to have partnerships with a lot of different types of launch suppliers to
Mhm.
get our products to space. Um, some, particularly in the pharmaceutical and
Mhm.
biology realms, they have to have really late access to
Mhm.
your payload, to your vehicle before it goes to space. They can only stay up there for so long. I think typically about like 4 to 6 weeks. After that, depending on the experiment, if it has kind of cells, they might die. You can only give them so much food on the way up there.
Mhm.
They have to be fed. And then to some of the technical challenges is
Mhm.
that getting to space, like I mentioned, it is very difficult. We have to operate. We have to maintain extremely high quality microgravity environment. So
Mhm.
this is microgravity. We're looking at 1 millionth of a g.
Mhm.
And even lower than that is actually much beneficial and wanted by companies looking into such material science type experiments and manufacturing. So any types of
Mhm.
vibrations caused by onboard systems, the atmosphere creates disturbance. Even the solar radiation creates a disturbance. So just being able
Mhm.
to know what that is and how you can mitigate those to maintain that best environment for whomever is manufacturing on board is a challenge. Next to that is bringing something back from space. So
Mhm.
right now, when you fly an airplane, you're going about 70% the speed of sound.
Mhm.
Um, the fastest aircraft was at the SR-71. I think the max speed it ever went was like 3.3 Mach
Mhm.
3.3. When you're coming back from orbit, you're going about 25 times the speed of sound. And
Mhm.
not only do we have a shock wave in front of our spacecraft that's generating immense amounts of heat and pressure, I mean, there's also
Mhm.
legitimate chemistry going on because of this ionized wall of gas. So it's hard to simulate. It's hard to model.
Mhm.
There are very specific shapes that and geometries that you have to not adhere to, but take into consideration to maintain your stability. There's upper level winds
Mhm.
that we don't have instantaneous predictions of. The atmosphere itself is shrinking and contracting depending on the day and the solar cycle. So there's a
Mhm.
lot. It's an extremely dynamic environment, and there have been many failures trying to come back and re-enter the atmosphere. We also need to do it extremely accurately. And then also, this is a new field, kind of not quite every day, but there are loads of other companies coming up with great ideas and great solutions to
Mhm.
this space as well. So
Right.
maintaining a competitive edge in a specific
Mhm.
niche and capturing customers and opportunities is also kind of a challenge in itself.
There's certain partnerships that I'm sure is beneficial for you, and maybe there are some companies that are direct competitors. How do you kind of navigate that environment of maybe knowing and like seeking the right partnerships?
Yeah. I think it's there's you can have partnerships or there could be overlap in kind of the services that you were
Mm-hmm.
trying to provide, but also like a little bit of the technology. And sometimes you could offer similar technology, but it could be for a different
Mm-hmm.
type of service. So
Right.
we're always trying to think about how we can partner instead of compete. Um,
Mm-hmm.
it's you can never get on a call with an investor and say you don't have any competitors. That is just
Right.
kind of that shows which should make you sound really naive.
Mm-hmm.
But you can get on there and explain like like this is our differentiation, this is our niche, and this is
Mm-hmm.
some potential ways that we might be able to partner in the future, even if it's not happening now.
Mm-hmm.
For example, I don't actually even think we've talked necessarily about how we are operating, what our general service and technology is. But we're not just
Mhm.
building the reentry vehicles to operate in space and bring the products back down, but we're also going to operate
Mhm.
uncrewed space stations. They can be much
Mhm.
smaller than a regular space station,
Mhm.
and you can kind of rethink what one needs to be. You don't have to have humans inside of it. So we have these multiple pieces in space. In addition
Yeah.
to those, there are also
Mhm.
crewed space stations. So you can think if
Mhm.
we're building uncrewed ones and there are crewed space stations, it sounds
Mhm.
like we're competitors.
Yeah.
But we put a lot of effort to saying, and making sure that everybody knows that like that is true. Both of these do exist, but that doesn't mean that one can do all of the things that the other can't.
Mhm.
We still want to
Right.
deliver and return supplies to and from not just the International Space Station, but the many that are being
Mhm.
developed right now that are either NASA funded or kind of from other types of companies as well.
Partnerships can definitely strengthen you. And I think at the same time, keeping in mind what makes you unique and differentiating your business, that definitely makes sense. I think because it's more of like an emerging technology, there's more potential to create like a much bigger like value in general. And I think you can think about how can I capture more of that value. And I think that's where you get into that more of like a competitive stance. So the next thing I want to kind of get into is what role do you think in orbit airspace is going to play within this new technology that we're discussing here?
Gotcha. Yeah, this is
Hmm.
this is a thing that obviously we spend a lot of time talking
Yeah.
about. Um, when I mentioned that we're building two different parts, a part that
Hmm.
stays in space and a part that goes up and comes back.
Hmm.
It's what we really are, kind of like third party logistics for manufacturers in space.
Hmm.
We want us to provide a service that our customers can give us
Hmm.
their raw materials and just like fully know and trust that they're going to get their finished product back.
Hmm.
So reliability is a big part of our company. It's a big value we have. Um,
Hmm.
but also in order and also being able to make it low cost as well and be able to ship as much product as they can. And that's what drove us to that specific architecture. If
Hmm.
we can leave the manufacturing labs in space, if we can leave any associated equipment that we would take up and down if we were just one piece, we want to
Hmm.
be able to leave that up there. It
Right.
lowers our spacecraft mass. That directly
Hmm.
equates to money through launch cost. It also frees up
Hmm.
the full payload bay for what we ship up and down for the
Hmm.
materials that our customers are making. So launch right now, depending on who you're
Hmm.
launching with, can be 20 or 30,000 down to about I think $6,500 a kilogram is what
Hmm.
I think the lowest price is. But these materials can cost 100,000
Yeah.
to even millions of dollars a kilogram. So we want
Hmm.
we want them to make more revenue. That is infinitely more. It's not infinitely, but it's 10 times more valuable
Hmm.
than lowering launch costs. Um,
Hmm.
while kind of going on that journey of figuring, really detailing out what that service and what that technology looks like, we
Hmm.
found that if we're going to get rid of an astronaut, we do have to do what they do
Hmm.
robotically in
Yeah.
space at some level. We're not going to create
Hmm.
a complete robotic astronaut, but we are developing the basic technology to take things from
Hmm.
point A, which would be our reentry vehicle, to point B, which would be the orbiting station,
Hmm.
and the reverse the process. We need raw materials one way, finished products
Hmm.
the other.
Right.
So that's the technology we developed, we patented that, and we've
Hmm.
also started to see a lot more use cases for it, aside from
Hmm.
just helping manufacturers.
Hmm.
This is kind of turning out to be a little bit of like a basic building block, a conveyor belt
Hmm.
in space, if you will.
Right.
Just being able
Hmm.
to, we have in space mobility with things being able to provide propulsion and get into different orbits and get to different assets in space. We don't yet have a reliable way of just transferring something from this spacecraft to this spacecraft, even after they're
Hmm.
docked and connected. And that's
Gotcha.
that's valuable for servicing satellites. It's valuable for
Hmm.
to help the companies that are trying to refuel satellites. They'll need that capability.
Hmm.
U.S. government Department of Defense, they talk about delivering cargo anywhere around the world from
Hmm.
the kind of orbital depots in space. It's going to be really valuable for that. And so that's the long term is we're trying to build technologies that can fit into
Hmm.
kind of every different subsector of the space
Right.
industry, and that is through kind of like satellite to satellite mobility.
It's definitely super insightful to hear you explain the different elements of the business and the technology itself and how the service works and some of the difficulties with re-entering and the challenges around that and being able to solve different aspects of this whole supply chain that you're trying to set up. So it's very insightful to know all of that. I think I want to get into a little bit more about roadblocks. What is one thing that you had no idea how to do, and you have to kind of figure that out as you were going? How did you deal with overcoming that obstacle?
I think, the biggest one would probably be like raising money
Hmm.
and talking to investors. That's something
Yeah.
that's when there wasn't a
Hmm.
raising money for physicists and scientists and engineers in school.
Yeah.
And
Yeah, certainly.
my family, yeah,
Hmm.
sometimes you might grow up in a family and like they do business and they raise
Hmm.
money or they work with customers, and it might
Hmm.
be easier for them, but it wasn't for
Yeah.
me
Hmm.
or the other co-founders. So we had to learn a lot about that in the beginning.
Hmm.
Getting connections, what were all the tiny little details of fundraising, how you hold a
Hmm.
fundraising round, how you like instead of just getting an investor to be like, that's really awesome, keep me updated,
Hmm.
get them to
Yeah.
actually want to invest. And it's a
Hmm.
lot of I don't know, there's a lot of psychology involved,
Yeah.
unfortunately, and
Hmm.
sometimes there's a lot of maybe acting a way that you don't
Hmm.
necessarily want to, but you kind of have
Yeah.
to. Like I'm not exactly the type of person that's gonna always
Hmm.
gonna like schmooze or
Yeah. Yeah, I can sense that about
try
you.
and yeah, thank you. But you find that there's a way that you could do it and
Hmm.
still kind of like be yourself and
Yeah.
maintain a little bit of your own integrity.
Right.
But that did take a lot of learning how to do, and we
Hmm.
were really fortunate to be able to overcome that just because of other people who believed in us. So we've been
Hmm.
lucky to go through a couple accelerator programs to really
Hmm.
help build our network,
Yeah.
notably like Techstars and recently the
Hmm.
Amazon Web Services space accelerators.
Hmm.
They provide you with loads of different people all along commercial space industry, as well as
Hmm.
government space industry, that are just like really really humble and really nice and really
Hmm.
giving people that will just answer questions, tell you what you need to know,
Hmm.
give you information, connect you with other people, help you
Yeah.
out, give you advice and feedback, and that
Hmm.
has helped us a whole lot.
I think most VCs, they look to see if the technology or the product is in the hands of someone who can be an executor. And I think if you pass that test, I've heard like most VCs, like that's what they look for. I'm glad you got those opportunities. So the next question I want to ask you is there a message or advice that you would share to aspiring entrepreneurs?
Yeah, I think maybe three general pieces of advice I
Mhm.
typically like to give. Order. Let's see. I guess the first one would be like, just
Yeah.
talk to as many people
Mhm.
as you want.
Mhm.
And while you're doing that, it's like
Mhm.
if you're emailing and you're trying to reach somebody on LinkedIn, like, and they don't respond, like, never take that as a symptom or a symbol that they don't want to talk to you. It's just
Mhm.
it's the I think the term is cylinder. Like, everybody has crazy
Yeah.
stuff going on in their life all the time.
Mhm.
It's rarely ever personal. So
Mhm.
like, don't bug them every day, but like, follow up.
Mhm. Yeah.
Because the second or the third time or fourth or fifth or sixth that week or month or something that you've reached out to
Mhm.
them, like they likely will come back to, and they
Mhm.
might respect the small hustle you've put in.
Mhm.
Um, the second and third are pretty related. The second is
Mhm.
like, always try and hold true to like why you're doing this. Like, remember exactly
Mhm.
what motivates you. And maybe try and associate it with a something, an object, a
Mhm.
song, that when you really really need that motivation, you can go and get it. Because what really sucked about doing this while like having a job, as mentioned earlier, is like you come home, like I was
Mhm.
a systems engineer, I would do
Yeah.
spreadsheets and documents, I would sit in front of a computer all day,
Mhm.
and then I'd have to come home and I'd have to sit in front of a computer all night because I have the startup that I'm
Mhm.
trying to get off the ground.
Yeah.
um, So yeah, you have to remember that, and remember that it is hard work, and you could probably be, doing whatever makes you happy, going out and having fun with friends, or watching a show, playing a video game.
Hmm.
But that doesn't always happen.
Yeah.
The counter side of that is you do have to take some time off occasionally, even if it feels like you have all these things to do and you're going to miss out on opportunities. Taking taking care of your own mental health is just as important, and at the end of the day, it's probably more important because um, you can start multiple companies, but you can't. Your
Mhm.
life is the only one you have.
That's amazing. I definitely resonate with the advice that you gave, and I think that's something that most people can take and apply to whatever that they're working on. So that's great. Thank you so much for sharing that. So next, I want to
Mhm.
get into the closing segment, and there's one question that I want to ask all of my guests. So the question is, what is your word of the year or this chapter of your life?
I think I think one that we've used pretty often is paradigm,
Mm-hmm.
and it is kind of like a new era of space. It's a new era of like looking things, and it's a
Mm-hmm.
new era of creating new paradigms. It's kind of a fun word to say, but it also like has a lot of meaning.
Mm-hmm.
I don't necessarily have like a profound reason on why that is the word of the year, but if there was to be one that has
Yeah.
probably used more, that would be it.
Yeah, that's definitely
Yeah.
like it's the most interesting word that I've gotten so far. So, and I think it's very
Okay.
fitting with your company as well. So it makes sense maybe why that word resonated with you. No, that's great. Thank you so much for sharing. And thank you so much, Ryan, for coming on my podcast and talking about yourself, your journey as a founder, and your company in Orbit. And I can't wait to see the future applications and use cases. And follow along your journey. Thank you so much.
Awesome. Thank you, Lavanya. It's been great to be here.